All right.
Hi,
Hello,
Alex.
everybody. Hi, Michael. Good morning, good evening, good afternoon, everybody. And thank you for joining our AuraDB live stream. Today we have episode 5 of season 2, and we talk about Stack Overflow data import from S3 and dashboarding. So a long title today. If you're wondering what this is all about, and you're new to the series, we take an Aura free instance usually, or an Aura instance in general, and play around with data a little bit, get a database going, show you new features, new capabilities, and show you a little bit of what's behind the scenes around Aura. And today we do look at the new data import tool, not as usual with a CSV file, but directly from a CS3 instance. And we play a little bit with the dashboarding tool. If you don't know Aura, there is a free version that has 200,000 nodes and 400,000 relationships, and gets you going and gets you, to play a little bit with GraphDatabase in the cloud. No installation needed. Just sign up with your email and, dive in. And
Now there are also 14-day free trials as well, right? So for larger instances.
Exactly.
So if you want to try out new larger data sets or more features, then there's also like the free trial that runs now up to 14 days for free. So you can also try graph data science and other things as well. Awesome. Yeah. Cool. Really looking forward to try some of these larger data volumes today. Let's see how well this goes. And yeah, so unfortunately, I just have 30 minutes today, so we need to be quick. So I think without further ado, let's get to it.
Quick and fun.
See how far we get. Exactly. Yeah. So let me share my screen. And as Alex already mentioned, we have recently released the ability to import datasets, both Parquet and CSV and TSV datasets from cloud buckets as well. So you see here AWS S3, Azure Blob Storage, and GCS as well, Google Cloud Storage. So you can basically pick one of those and then basically configure your data source name, bucket paths where you map individual files or file selectors with wildcards to table names, kind of virtual table names, kind of like, let's say in our case, it's something like users or posts or so. Then you provide your S3 credentials and optional endpoints if you have like custom endpoints, or if you have a special region, then you can add this and provide this information, and then you can get started. So I've already done this today for this data set. And you can here see the StackOverflow dataset, which actually, I looked it up. To this day, it's almost 10 years since I first imported the bulk dataset from StackOverflow. Back then, they had the celebration that they had 10 million questions, basically, in 2015. And they published their data on a public license. I don't think they still do it because of AI scraping and all the other things. But at least up until last year, they used to publish their data also on a public license. And here in this blog post back then, I showed how to import it with the bulk importer to Neo4j itself. So a while ago, I prepared these files not just as CSV files but also as Parquet files. So you can basically also access them from Parquet, and I did it for our DuckDB book that I wrote with my colleagues Mark and Michael. And so basically pulling the data from the Stack Overflow dump in the weird 7-set compressed format, converting and extracting the data to a graph model, as you can see here, right? And then exploring this, but then in the end also basically writing it to Parquet files that Alex already mentioned, right? So Parquet files is a columnar data representation format. So it's not like CSV text-based, but it's basically in each kind of section, they call it row groups in Parquet, of a Parquet file. Each column of data is stored independently and is then also compressed. So for instance, if you have a lot of repeating elements or specific elements that can be compressed really well, or like text is also compressed with lookup mechanisms and so on. So it takes much less storage and can quickly scan these columnar these columns of data for information. And Parquet files also have metadata, so you can basically use this to quickly select subsets of data as well, because it knows from the metadata where in the file, or does this file at all contain this kind of information. If not, it can skip it. So the Parquet files are really nice, and they're compressed and smaller. And there's an S3 bucket here with the files that I used in my config. Right. So I basically went ahead and stored this in this config. I also created an instance. This time I created a little bit larger instance because I wanted to look at the multi-CPU capabilities a bit, and also because the import is faster with multiple CPUs. Because this is not a bulk import like the one that I demonstrated in the blog post, but this is an online transactional import. So your database can keep running while you ingest this data behind the scenes as such. So I created this instance of 10 CPUs, but I will scale it down later afterwards after the import is done and like all my updates are done. I can scale down this instance again. Right, so I have this instance now, and I can basically configure my S3 bucket here with the details. So I have kind of these file names. These S3 file names are mapped to tables. So you see that the text file is mapped to a text table. Post file is mapped to a post table, and users Parquet file is mapped to a users table here on the right side, right? And then I provided my S3 credentials as well, and the region as such, right? So pretty straightforward mapping of your data as a data model. And then I basically went into graph data models and had it create a data model for me. There's some interesting tidbits about the StackOverflow dataset, which makes it a little bit complicated. So for instance, something like all the questions and answers are stored in the same table, in this post table, basically. So they're not separated from each other. So they're all like in one big table with a lot of optional columns as such. So that basically you just get a post, and then you have, after the fact, basically decide what's a question, what's an answer. And it automatically mapped for me like all the files and virtual tables to nodes in the graph. And also the attributes defined what is the key. And then for each relationship, I could then also use one of these virtual tables basically to say who's the last editor. I take this from the post table, and it maps from a post last editor user ID to an user ID. So I get this relationship, or for instance, the posted relationship, which maps from a user ID to an owner user ID in the post table, right? So it's kind of the typical foreign key mappings that you have. In this case, it's actually one-to-one mappings as such. And then you also have relationships that are self-relationships in the post table. So for instance, if one post answers another post, then there is an parent ID in the post table that basically points from the question, from the answer to the question, and also accepted answer ID, basically, which points from the question to the answer as well, right? And we basically use these ID mappings. And then I run the import. I won't do this right now because it takes a while, but I can show you in the jobs basically that it completed. So I ran this earlier today, and you can see basically we had this job importing 58 million question and answers, 64,000 text, 20 million users, and then in total about, how much is this? 60 million relationships or so into the database as an online import, right? So it was not like a bulk import offline, but it was an online import. I think we can still improve the performance here, but that's at least a good baseline to get this volume of data in as such, right? And then what we can do is basically start exploring our data. So we can go to query and start basically looking at the data. So we see we have 78 million nodes and 62 million relationships in here. And so, for instance, I can look at which questions were answered by which text. So I see basically the question here in the middle with all this information, like how many answers does it have, how many comments does it have, when was it created, how many views, how many up and down votes, who's the user that owns this question, kind of tags, title, and so on, view counts, and so on, right? So, and this is the whole history of Stack Overflow. So from the very first question to the one that was available at the when I downloaded the dataset in 2022, basically. as such. And then also all the relationships are mapped here as well to the answer as well, right? So I can see all this data, and this looks actually quite nice. And then I can basically start running some example questions here. So for instance, I can say, find me users with the most questions, that posted the most questions, and then basically give me the top 10 users, right? So I can say basically user dot name. Is there like a screen name also, display name? And count star, order by count descending limit 10. And because now I have an database with a lot of with more CPUs, I can actually run this as parallel runtime. So if I run this directly, it will take it a while. But if we say cipher runtime equals parallel, this is like an analytics query, then it can run this query with multiple CPUs. And then we can also use some.
Do you have to define this every time you do a query, or is there a way of saying every
yeah,
time
because
I
it's
run
kind of a pair query
use
thing, right? So you would basically in self-managed, you can also configure this globally, but because in an instance you usually have a few queries that are like global queries that query everything, you would do this per query as such, and not usually as such globally. Only
every
if you have
time?
a dedicated, let's see, read replica instance that's only used for analytical queries, then you can specify this also globally as a flag, because otherwise it does not make sense, because of course this parallel execution kind of takes some more management overhead, but so for small and fast queries it's actually not necessary, right? And we can actually simplify and speed this up as well. So we can also use the count expression here instead of using this. Come on. And if you remove the label here, so we can actually do this, and with view comma count return u dot display name comma c. So this should actually run faster, as you saw that, and it should probably.
But it didn't count.
Order by. This is not correct, right?
No. Oh.
Because these are like the wrong counts.
Yeah.
This is weird. Did you find an issue again, Alex? You're like the good bug hunters here. So this should actually not happen, right? With user count star, order by user descending limit 10. Interesting. I think we found something that we need to look at. Anyway, so you can do lots of interesting other things as well. So one other thing that I wanted to do is basically look at the post types. So I mentioned already that currently these posts have both answers and questions in the same thing, and they are basically differentiated by post type here, right? And post type ID 1 is question, and post type ID 2 is actually answer. And I wanted to show you how you can now. No, but my query needs then count you posted. Oh, sorry.
Is posted user not posted existing question. As a no cost is there? Yeah.
No, there's posted.
Yeah, that's posted. Yeah, I see.
Anyway, I'll figure it out, and let's see. We can run this in the background. So no. Okay, I look at this. What went wrong here a little bit later. But just to make progress is I wanted to show you how you can do these kind of global updates as such, right? So because we have a lot of data in our database, and I thought, so I already tried it out for updating the question or adding the question label to posts that have post type ID 1. And you see it at 23 million labels in 42 seconds. And if I said post type ID 2, and that's an answer basically, and it can run this in concurrent transactions because it has multiple CPUs now, it can basically do concurrent updates here. And if I run this, it basically spins up basically 10 different threads that in parallel process this data that's passed into this subquery here, and then commits after 50,000 batch rows, basically the updates, and then should do another 32 million or so. And you see it already starts to commit here these queries, so it basically starts to add this label already. So we can actually also see how many answers do we have now here. So it has, what is this? 1.9 million?
1.9.
19 million already.
Oh, 19 million. Yeah.
So it's already quite far. 23 million, 26 million, and then it should be done soon, right? So it's basically the last few million that are updated. So I think it's 32 million in total questions. So something like this should be, let's see. Yeah, I think now it's done, and now we should also see that our response down here is also done. So it basically added 34 million labels in 1 minute, right? So it processed quite a bit of data in a short time, right? So that's actually quite good. So that's one kind of update that we can do, right? And another kind of update that I wanted to do is an interesting one, because if you look at this data model here, where's my data model? Here's my data model. StackOverflow. You see that this text table is not really connected to the posts, right? So it kind of sits in isolation somehow, right? And that's because in Stack Overflow, it's super weird because how they do it for performance reasons, I guess, is they store the text into a string attribute. So you see this string text down here, right? So which is basically in angle brackets, like in HTML almost. Like each tag is in one of these angle bracket pairs here, right? So and then basically, if I return this here directly, then you see that it's basically like each question has like one of these, right? So they are not actually mapped directly as in foreign key relationship, but they are basically contained inside of the inside of the post, right? And so I thought, why don't we use the power of the graph and connect the questions to the tags as such, right? And so just before our session, I started to look at this. And what we can do is basically, as you can see here, we can match our questions that have not an empty text string, right? So where the text is not empty. And then basically just split this at the angle bracket boundary, right? So where the two angle brackets meet, that's kind of where one tag is split, right? And and we can basically let's see with q limit 10. So basically we take 10 questions, and then if we split this, then we see that basically for this question, the tag is or the list of tags is this. And then what I can do is let me actually just return q.title, tags. So this is basically the list of tags for this question, right? So I have like 7 also tags. Right?
Okay.
And now we can actually take these tag names and find the tag nodes that we have in our graph, right? So because we have all these tag nodes in the graph, right? Linker errors or CSS or code metrics and so on, right? So we can take this and find this again. So we have our tag, and then we can basically show what the tag looks like for this tag that we looked up, right? So the idea is, can we actually, I forgot something, create constraint tag name on for t tag, assert require t dot name is unique. And I always misspell the constraint creation. But this time I remembered it correctly. So we have now a new constraint tag name. And if I do show constraints, there were a few that were created by the input process, right? And now I have the constraint here as well for the text. So that means when I now run this query that we just had, it should be, first of all, it should be faster because these tags are now found quickly. And now what we can do is basically we take this information and say we do another of these subqueries basically and say we find our tag and then we create a new relationship from question with tagged to this tag basically, right? So that's our new relationship that we find. And then we say in concurrent transactions
we create. So as you can see at the left, this relationship tag is currently not existing. So we added.
Exactly. So it doesn't exist here. No? Right? So and if I didn't do anything wrong, it should now go ahead and create for the 20 million questions, perhaps 200 million tag relationships or something like that, right? So because each of them has, or perhaps not 200 million, but let's say perhaps 70 million or something like that, right? So perhaps it has on average 3 tags or something like that, right? So now it can go ahead and create these relationships. And you see it starts to add tagged relationships here, right? So we now see like each question has several of these colorful tagged relationships. So that kind of, these are the tags that define a question. And then if I use one tag like indexing and double click it, then I should see all the questions that are connected to this tag, right? So which is a lot. Right. And so it's now built up the like almost like a taxonomy in our graph as such, right? Okay, so it's busy doing this, and we can actually, let's see, we can actually run a count query here as well and see how many tagged relationships we create. So we currently have 99 million, right? And it continues to do this. And while we're waiting for this to finish, I thought the next thing that we can do is actually look at dashboards, right? So we have shown dashboards a few times, but I just wanted to quickly show how we can use AI to give us an initial dashboard, and then we can modify it and make it a little bit better and faster. So for instance, I have a Stack Overflow database, create a dashboard with some EDA charts and graphs or networks. And note that this database has a lot of data, so make sure to limit each query to 50 to 100 results at most, and use Cipher runtime equals parallel as a prefix. So let's see if it does this. When I tried it earlier, it didn't do the prefix, but let's see if it does it now. So it would go off and look at the schema of the database using my prompt to generate the dashboard and go ahead and do this. So it should only take 10 seconds or something like that to generate
I did an episode with Niels a few weeks ago on the whole dashboard feature in Aura. So if you're interested in seeing more on how to create dashboards, how this works, I'm recommending you to check the episode out. I'll share the link in the description and in chat.
Yeah, cool. So, and you see it starts to get some data back here already. Users, so we see already users by reputation has returned already. So we see, as expected, Gordon and John, who are like the top Stack Overflow posters, are on top here. And then basically we can go further down to people by reputation. And you see, if you look at the query, it's actually still a regular query. So if I do Cipher runtime equals parallel, I can make these queries faster as well. And then it finishes faster returning these queries. For tags, I think currently also still uses the text table. So I also can prefix this if I want to. So then it's instant almost, right? So you see that JavaScript is the most popular one, followed by Python, followed by Java, and so on. So that's also really nice. I see distribution of post types where we now know this, like these ones are the questions, these ones are the answers as such. And then there's a bunch of other post types like Wikipedia entry posts and a bunch of other specific meta posts and so on. But 1 and 2 are the most frequent ones.
Yeah.
And then we can look at the question answer network. So we see some questions and answers. We could also add now here our users, for instance. So for instance, if I want to also see the user who posted the question, we can also add the user who posted the question. Then we can also add this, and instead of returning the individual ones, we can just return the path here as such, right? And then we get also here the user, and then we can also see basically if we have users. I'm not sure if this is in the data. Users that posted answers as well. Let's see if it returns anything. Yeah. So now we see basically users that. Or is this? Let's see. Is this also a user? This is also a user. So this seems to be not correct from a data model perspective, right? So we have so many users posting the same question. That's not really what we wanted to. So I need to look at this second part. So let's ignore this for now in my mapping. But you see that you can get to a quick overview of data pretty quickly. And then you have some of these queries that might be post creation date. And here we could also say Cypher runtime parallel. And we want to, it's ordering them by creation date and view count, which is a pretty large query, right? So basically posts by creation date. So let's see if we can make this faster, or perhaps we can do questions instead of posts, and see if it can compute this as well, right? And then there's also like user post count views, scores by post type, and things like that. So we can basically look at these and see basically which are the users that got most views on their posts on average, right? So that's who have posted the most posts, which are mostly not answers, but might be also questions, right? So for instance, here John Skeet is here, but Alex has perhaps more questions or so. There's also some users who posted a lot of questions as well.
Lots of questions, yeah, for sure.
Right.
And just to remember everybody, everything has been auto-generated or AI assistedly generated. So it's really nice. And you can always add your own views, and like Michael does, or edit the ones, but
modify it.
You can quickly get a nice start to a dashboard with this too.
Exactly. So and now our tags. Let's see how many questions we have here now. Let's see. So it should have finished this. Oh no, it didn't finish it. So I probably have used too much memory for creating that. So you probably need to reduce this to 10K or something like that, and then rerun this. But in total, we should have gotten quite a number of tagged relationships, right? So we have gotten already 39 million, 30 million, or 40 million tagged relationships, right? So I would probably adjust this and rerun this and change this to merge instead of create, and then it would only do it and not access queue. Actually, you can do it like this. Right, so where we say we don't have tagged relationships yet for this, and then we can still use create here. Right? And then we can say 10,000 rows, and then it would go off and create the remaining text for us as well. Right. So, and I think with this, except for this one issue that I need to look at, where the posted relationships seem to be weird. But you saw that also in the dashboard, there was something weird with the posted relationships. I probably made a mistake in the import mapping as such. But
maybe.
In principle, I just wanted to show you what this looks like basically from an import, dashboard, and query and update perspective as such.
Yeah, super easy, and if you have already databases in other locations, then you can now import them through the importer tool directly into Neo4j. The data modeler, the data is also very easy to map against from your tables to a graph. I mean, eventually you can also generate a model, so probably you can also load this off to some extent. I think there was a question. You don't have to create the model all by yourself. You can get that generated a little bit.
I think I used the AI generated model and then adjusted the
things,
exactly. If I'm not mistaken. Yeah. Cool. And with that, I think I covered everything that I wanted to cover today as a quick overview for this as such.
Quick and easy. As I will be quick and easy to wrap this up because we need to go. Exactly. Yeah. Rewatch if you like. Maybe it was a little bit fast today. I'd like to invite you on the next stream that's happening on the 21st of August, so on Thursday, where Paolo and Maximilian will join me to talk about smarter collaboration with AI knowledge graphs. So a little bit on the backside of team managing and team building with AI as a back end. So that should be fun. Notes, if you want to know more about it, and you can register for it already, get on the waiting list. The agenda will be updated soon or published soon, and Road to Notes is going to happen also in September. Also, that will be shared with you in a few more days. So probably by the end of the month, we will know more about the workshops and the agenda for Notes this year. So I'm very much looking forward to this one. And yeah, if you like to know more, if you want to learn some more stuff, Graph Academy is always open. Great place to learn, especially about AI, but also about Neo4j fundamentals. We have a great course training path for you, Aura free. If you're interested more, get started with Aura free or with the Pro 14-day trials that are now available. So it's a great place to check it out. You don't have to do anything except to register for it. And our developer pages have added new tutorials. Michael, you wrote a bunch of new stuff on MCP, on GraphRag, on Knowledge Graph. So there is a great place to learn more, and if you want to get into that. So happy for you to check it out. If you have any questions, any comments, the community is always open. Check out our forum or on Discord and let us know what you are currently building or what you're struggling with, if so, and we'll be able to help you. And yeah, with that, happy Monday, everybody. Enjoy the rest of your day, and I'll see you soon.
Have a great week, everyone. Take care. Bye-bye.
Thank you. Take care.